All right, fantastic. We're going to let everybody funnel in. It just hit 6 p.m. Welcome, welcome, welcome. All right, we have the attendees funneling in. We'll give everybody a few minutes, but thank you everybody for taking the time out of your busy evening or your busy morning for those in China. We see the numbers going up. So yeah, we'll just let everybody pause for a minute, but we're very happy to have our Director of Education, Peter Alexander, here with us tonight to talk about a very exciting topic, that BEC competition, about competition mathematics, whether that's AMC, AIME, so many important competitions that a lot of our students are interested in. So we'll maybe give it one more minute for everybody to join.
Thanks, Jonathan.
Mm-hmm.
Yeah, it's good to be here.
Great, great. I know we're still in the quarantine.
That's right.
But it doesn't mean, you know, we can't still communicate with our students all over, all online, in the quarantine, out of the quarantine. We're often meeting online.
And it's a great time to study, catch up on all your research.
That's very true. That is the bright side of the quarantine, you can say. All right, so let's see. We already have something in the chat. How long will the meeting be? So we plan for these to be about 1 hour. And so, you know, if you can allot that time, that'd be great. If you have to leave early, it's okay. We will have recordings going up to our YouTube channel, to our Bilibili channel for those in China. So, you know, if you have to leave early, it's totally okay. And I think it's probably about time to hop in. But we wanted to say first that if you have any questions at any point, please ask them. And then we will make sure to answer them along the way, because some of this content is a little confusing, or anyway, it's higher level stuff. So we definitely want to encourage questions from the audience, whether it's students or whether it's, you know, teachers or parents.
Yeah, absolutely. It's okay to just chime in and interrupt me. And all I can say is I don't know. I don't.
Very good, very good. So yeah, let's just hop into it. Yeah, if you can go to the next slide.
Okay.
Sure. So yeah, we have a lot of people in the audience. They are very happy, and some of the names definitely recognized. And some of these are our students' parents or students, but a lot of people who maybe don't know much about BEC. So we really focus on education and views. We focus on the future success of the student. The idea being that what are we doing all of our service for? What are we doing all this preparation for? Why spend so much time trying to apply to great schools? Well, the idea is not about the school you apply to. The idea is, what do you want to do in the future? The idea of attending a very strong school is to accomplish some kind of future goal. So it's our mission to work with students to help them better understand what that future goal is. And if they can do that, then suddenly the planning we provide and the opportunities we can provide can be much, much stronger. And in that way, not only is it strong for their own personal development, but they get into the school, that kind of dream school, because they become the student that colleges want. So they already have a strong vision for themselves. They have a strong record of achievement and extracurricular activities. And then when they apply to the colleges, the colleges can feel that, and they can sense, okay, you know, this is what you'll provide to our school. So we have our yearly mentor consulting program for younger students from middle school through high school, and even at some college students who do our mentor consulting program. Then we have application consulting. Application consulting comes from applying for high school, applying for college, and applying for graduate school. And lastly, but not lastly, a crucial portion of getting all of this done and becoming competitive and unleashing your true academic potential is the tutoring and test prep led by Peter Alexander. So all together, we can provide students with a strong team of educators. All right, back to you, Peter.
Sure, Jonathan, thanks a lot. And thanks for that intro. And that's exactly what we're kind of here tonight to talk about is this whole subject goes under extracurricular kinds of activities and things that students can be participating in that can really give them an opportunity to shine before various different types of schools. And it's really, for some students, it's a lot of fun. We're going to be talking about competition mathematics. And one of the things that's very interesting about competition mathematics, one of the things what I like about it a lot, is it gives many students who might not otherwise like mathematics a different window into math than they get in the public school system. What I found is that often students simply are bored with their in-school mathematics. They do very well at it, but it's not that interesting to them. And when I actually trick them by telling them we're going to do some puzzles, they actually find the puzzles fun. And then they learn that, oh, you got that from AMC 8 or you got that from AMC 10. That's a math competition. We're going to see a little example about that. And they get interested. And then all of a sudden they're tricked. And then they start learning more about this stuff, and it starts opening up to them. Of course, they still don't necessarily like their school mathematics, but their attitude towards math starts to change. They start seeing it for a little bit more what it is. And so we're going to talk a little bit about that. I hope to convince you that although it might sound hard, you're going to see with what I show you, I hope, that it really isn't, it's not that hard to actually begin to look at this kind of mathematics and to actually do pretty well at it with a bit of work.
Yeah, well, I think that's a great point. That we have a portion of students that love math, right? They want to hop right into competition math, but then we have other students who are a bit nervous to approach math, or it can feel like, oh, that's not their strength. But when you start getting into these problems and they start to see what they can solve in these situations that they can kind of figure out with math principles, and suddenly it gets a little more exciting. If we can change that psychological, kind of distance from math, it can really, really affect students' entire approach to STEM, and that's really huge.
It sure can. It can sometimes convert them from not sure what they want to, yeah, I'd like to go into physics or math or something that involves problem solving. Yeah. Okay, so what I'm going to actually start with tonight is an example of a student that I worked with a while ago, and I thought that, and this is actually kind of a typical example. Her name was Lillian. Her name wasn't really Lillian, but she's representative of several students that I've had, and this is what happened. She was this particular person that is represented by Lillian, it was a straight A student, especially in math, and had always excelled in math, was in the gifted program. And she was in Calculus BC in the 10th grade. She wound up getting a 5 on the AP Calculus BC exam. And she was going to take multivariable calculus in junior college, and it was suggested to her that maybe she might be interested in going to a popular Silicon Valley math camp. I won't exactly say what it was, Stanford University, and she decided to do that, and I helped her get into that program. We spent maybe about 3 weeks preparing to get through the screening process, and she was certain she was a math whiz, and she went to the camp, and she really loved the people. The food, she said, was great, lots of fun activities. But let's look at what happened. Unassisted, they have problem-solving sessions. Some of them are on their own and some of them are in teams. Unfortunately for Lillian, unassisted, she was not able to get any of the 60 individual problems that she had, not on her own. So she wasn't qualified for the math talent search, unfortunately. And she was defeated and discouraged because she had gone from always doing very well to all of a sudden feeling, what the heck? She loved the people, she loved the experience, but just this really left her feeling like maybe math wasn't her thing after all. And this has happened to more than one student, but I remember working with her explicitly on some of these issues. So she actually came back to me, and we talked about it, and the first thing that she thought was her formula sheets weren't lacking. You see, students that are in competitions, low-level competitions, they put together these elaborate formula sheets with the quadratic formula and maybe some factoring formulas and even material with sines and cosines and things like that. And she thought, oh, maybe her formula sheets, that she didn't study enough. Or maybe she needed more advanced courses. She didn't know enough. She'd only had Calculus BC. Maybe she needed something more advanced, maybe some undergraduate mathematics or upper division mathematics. Maybe that there was anything she do. This is what she was most worried about. Maybe there was just really nothing that she could do at all. What do you suggest? Well, I listened to her and we joked around about it. And I put together sort of a list of things that she learned up until this time in her math career. And she thought that doing well was about formulas and tricks. I mean, that's what we actually wound up concluding together. And that we thought that she had been thinking, trick A for problem A, trick B for problem B. Now, of course, she didn't listen to me when I was trying to initially tell her that this isn't the way it was. So when we initially were preparing, I just let her kind of rule the sessions. And but at this point, she was quite ready to listen. She had said, "Oh, I thought that if you master the tricks, you master the test." And we were beginning to learn that that wasn't necessarily true. And we then examined a bit about what she learned about problem solving, and she didn't think that there was much need for depth. She didn't like the idea of challenges and getting discouraged. She really wanted to just get the answer that was sort of her pattern, and she suffered from an experience that I call flash pan proficiency. And she got a lot of applause for that. And that's when they get the answer really quick before anybody else does. And then they move on, and they're not interested in exploring anything more deeply. They're not interested in structure. And that was what she had taken away. And this is what made the learning so challenging at the math camp. What should she have learned? What if she had been working with us a bit longer, or she had been coming to BEEC? She would have learned that mathematical fluency is not about tricks and rules. Mathematical fluency is about structure, it's about language, it's about understanding. And she would have learned that reasoning and problem solving are essential skills that she can't necessarily learn. We can't count on them to learn that in school, not at a deep level. And the key to Lillian's recovery was going to be that she had to relearn and unlearn the math that she had learned, so it would be useful to her.
And it's safe to say that, just so you don't mind me hopping in,
sure,
that this is a student who, by all traditional academic standards, excels to the highest degree in math.
Yes.
Finishing Calculus BC as a sophomore would put you pretty much at the highest level of any math students we work with. And so this is something to be said, that this sort of student could be, anyway, not to say off course, but that there's a disconnect between this academic achievement and then the actual math ability.
That's true, Jonathan. That's exactly right. Yes, and the system is not picking that up too.
Right.
That's
normal teacher is, you're getting an A in Calc BC, you're a math genius.
That's right.
That's the typical response.
That's exactly what we see all the time.
Yeah.
And so I kind of wanted to just highlight for everybody, the idea here is simply that strong problem solvers develop mastery of a relatively small set of tools, but they learn how to use them in depth, not breadth of understanding. And that's very different than the way a lot of very, very strong performing students in school actually think about things.
Yeah.
Okay. Let me get my mouse back here. I don't know what's going on, why I'm not.
Is it not going down? Uh-oh, we're having some
I'm having a technical difficulty with my...
Just the arrows, maybe? arrow down.
There we go. So I guess why study competition mathematics? That's my little next topic if you're looking up there at the top. So we can document at BEEC that advanced problem solving skills actually can be taught and passed on as knowledge. We have evidence for that because since people have been taking this more seriously, we have been starting, well, not just BEEC, but people that have been interested in training people for competition math have been working on this, and we've been starting to see the US actually succeed in taking first prize in the International Math Olympiads. And this, we've done it, I think, for the last 4 years straight. So we know that it can be taught because we had been losing, and now we have started to actually win. These skills are absolutely essential to success in STEM subjects in college. Yeah, I can tell many anecdotal stories about students who have done well with competition mathematics, who then went on and were able to adapt those skills from anything from computer science to organic chemistry. So these are very useful skills.
Yeah.
And what happens is they're almost always mistaken for breadth of information. Regardless of how Common Core tries to reverse this trend, breadth is not depth. Advanced problem solving skills are often equated with numbers of classes and subjects that students have taken, and that just is not true. So what is real mathematics? I thought it might just be a little bit important to touch on that. First of all, it's not memorize the trick, use the trick, forget the trick, or memorize the fact, SOHCAHTOA for sine, cosine, blah, 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 FOIL. It's not about memorizing the trick, memorize the quadratic formula, memorize the Pythagorean theorem, then use it, then forget it. It is about understanding logical relationships and their use in what I'm calling problem solving. I'm using that as a special term. That's going to be opposed to this idea of flash in the pan or flash pan fluency, where people are just trying to get the answer. And real mathematics turns out to be, I believe, the shortest path to teaching strong problem-solving skills. So strong problem-solving skills certainly include math, but are not in any way limited to math. They're used in every area of industry, both in political science and social science, in all STEM subjects. But it turns out that math provides a nice framework for actually introducing these skills. So problem solving is crucial in mathematics education because it actually transcends, it goes beyond mathematics. I think that you've probably seen some of that, Jonathan. Students that do well, not just at getting answers, but problem solving, they wind up doing well in other areas as well.
Yes, it's the you know, I'd say #1 skill, but that one skill that can take you out from, like you said, that pattern of memorize, use, and forget to viewing academics or the things you're trying to solve once again as true problems with methods that you can draw upon independent of being tied down to a specific worksheet or a specific lesson. The idea that you as a person are trying to solve problems, and therefore there's an element of critical thinking that comes in versus strictly just going over course material, you know, and cramming for it the night before, which can be done, and you can, and some students can do it very well and they can get A's, but then you throw something at them that they haven't seen and it's impossible for them to suddenly solve for it. While other students may not have the same grades, but somehow they have the problem solving techniques.
Yeah. This is what we see, you know, all the time. I have a friend who went into Bolt Law School, and he came from the logic department at UC Berkeley, and he didn't understand why it was so difficult for some of his friends. Well, for him, he saw how the law was structured around a few basic principles, whereas these memorizers, forgetters, it was all these things that they had to understand individually, and they didn't have a central organizing principle. They didn't know how to look for central organizing principles.
And that can be very frustrating. Like you said, that student felt like everything they knew is gone. That doesn't matter anymore. And they're kind of correct. It kind of doesn't matter anymore. They're not wrong, which is the thing. So there is this period of unlearning and willingness to relearn if they're really dedicated to advanced problem solving.
Okay, so the second, if you're looking up there at the top, it says, why competition mathematics? And so let me return to that question a little bit. And here's my answer. Competition mathematics provides a well-organized framework and context for both learning and practicing problem solving. And so that alone, I think, is the basis for that. And you can take those problem solving skills into an organic chemistry class. You can take those into a music theory class. You can take those skills into a law class. And it's, I think it's just very useful.
What you said is very important. This is in contrast to the belief that the purpose of these competitions is to get into college. Now, can these competitions help you get into college? To a certain degree, yes. But why would they even help you get into college? Because they prove that you have these skills, and colleges value these skills. So yes, the competition in that award can represent the skills, but in reality, the school wants the skills. So it's just the vehicle to express that.
Yeah, we're going to talk about that, and I think in the next slide. So many parents see.
Yeah, sorry, I overshot it.
I had no problem. So my next little, if you're following along at the top there, so these competitions have become popular in many pockets of education, because many parents see that kids need to develop a love of problem solving outside the classroom, because too many classrooms are failing to develop kids' interest in solving problems. Classroom challenges are often at best mediocre. That I would like it to be different, but those are just the facts, unfortunately. There are going to be, check this out, over 1 million STEM graduates needed within our workforce to meet the demands of our technical society by 2022. And STEM, this is what you're getting at a little bit. STEM schools now actually request competition math scores. They're actually interested in just seeing how you did. And you don't have to do great. They just want to see, did you even care? Did you even, take your skills, your problem solving skills, and look at it in different areas. Some well-known competitions are, one of them is Caribou. This one is actually interesting. It meets 6 times per year. It's for grades 12 and grades 1 to 12. And this one's nice, especially now. It's online. And all of these things, you can ask us some questions and we can put you in touch with resources about how to. Another one that's really popular, it's probably one of the world's largest, I figured I'd mention. It's called Kangaroo Math. Lots of really nice, interesting, and they get problems that are fun for kids, grades 1 all the way till high school. That takes place in late March. Then there's a Math Count, which is generally for 6th to 8th graders. It varies from state to state and location to location. That happens in February. And for tonight, at least, what I'm going to focus on is I think one of the most venerable and oldest ones in the United States, and that is the AMC. That stands for American Mathematical Competition. Can you guys see my little hand? I don't want to click the arrow again and get stuck.
Yes, I think I can see the curve.
You guys can see the hand. Okay, so this is not one. This is actually a course, and I'm going to explain this a little bit more here. We're going to focus on this whole course of discussion here.
Right.
And what happens here. These are all sponsored by the Mathematical Association of America and National Council of Teachers of Mathematics.
And Peter, you're a member of that, correct?
I am a member. That's why I had its.
I would try to apply, but I think I'm a fraud.
No, actually, if anybody can be a member if you pay. You're always invited to be a member if you have participated in their activities and so on. So. But I'm going to explain this whole, basically, Mathematics 8 is sort of AMC 8 is sort of a warm-up competition, getting kids in shape for the idea of advanced problem solving. AMC 10 and 12 are screening tests for the invitation. This is called AIME, is called American Invitation Mathematics Exam. And if you do well enough on the on AMC 10 or 12, I'll say a bit more about that in a second, then you will be invited to participate in this one. And if you do well enough in on the AIME, then you will be invited. You could be invited to the Harvard MIT tournament and or the USA Mathematics Olympiad.
If you don't mind just chiming in, the 8, 10, and 12 correspond to 8th grade and under, 10th grade and under, 12th grade and under. Just to...
I'll say a bit more, almost.
Sure,
almost. I'll say a bit more of that later. Okay, we'll get to that in a little bit more detail, but that's almost the way it is. Yes.
Okay, good.
Okay, so anyway, the Harvard MIT tournament is probably the most difficult, challenging mathematics competition in the United States, if not the world. And so students who are invited to go to that, they really are. This is quite an honor to, at least, even if you're just invited, it's quite an honor to put on your application.
Right.
So let's talk a little bit about AMC 8. It's just the structure of what AMC 8. That's the first one. It's sort of the one that prepares you for what the ideas of competition are about, the kinds of things that you'll see and how it is different from your school mathematics. So first of all, the structure of the exam is it's 25 questions, and the students are given 40 minutes in increasing difficulty. The problems unfold in increasing difficulty. They involve all areas of Common Core mathematics up through 8th grade. So this includes sometimes 5th grade, 6th grade, 7th grade, all the way up through 8th grade, and actually sometimes 9th grade too.
Okay, true.
The last several questions of, we'll have a bit of an example in a second. The last several questions of the exam tend to be the most challenging. It's open to all students. I've had students in the 4th grade who've taken AMC 8, in the 5th grade who've taken AMC 8. It's open to all students, 8th grade and below, as long as you're 14.5 or less on the day, or I think it's strictly under 14.5, I don't know if they'll fudge it too much, on the test day. Okay, so as long as you're under 14.5 on the test day, and in the 8th grade. So if you're a freshman in high school and you're under, that's not going to work. What to expect? Okay, I'm going to give you a little bit of an example. I did this and we had some fun with my our last seminar when I gave the audience a problem. So here's an example of a school mathematics problem that might be considered a bit challenging. I'll give you the problem. And so this is the school challenge problem. Anna's 36, okay? And when her mom was her age, Anna was 10. And we want to know, how old is mom now? Okay, so why don't you guys take a moment and think about that. I'll give you 30 seconds. I'm looking at a timer here. And see if you guys can come up with the answer.
Please submit your answer into the chat. We're very curious to see our audience's answer. 36. When her mom was her age, Anna was 10. We have a couple of different answers coming in. We have not just a couple, we have 3 different answers. Okay, let's go into the chat. When is the time, Peter?
We're almost done.
We're almost done.
And
all right.
Let's stop.
Sure.
I'll give 10 more seconds.
Okay. We currently have 62, 56, 72. We have a few different answers. 62, 56, 72. Okay. So let's see. What is it?
Okay, let's stop. Okay, so I believe the answer is 62. Okay.
Ooh.
Now, at the risk of ruining everything, I'm going to try and show you why a little bit, because it's important. So if we let Anna's, this is what we would do in school. If we let Anna's age be, because we know that Anna's age is 36. Mom says, or we know that when her mom was her age, so when mom was 36, Anna was 10. So the difference between mom's age minus Anna's age, so when mom was 36, Anna was 10, so the difference is 36 minus 10, that is 26. So, okay, so the difference between their ages is 26. We're okay so far?
Yeah, I'm on board with that.
So Anna is 36. We add 26 to 36, and we get, last time I checked, 62.
Yes.
Okay, so Anna's mom is then 62. Now the clever insight why this would be a challenge problem in the school is because you had to observe this idea here, their difference, and then you had to add that difference to Anna's current age. Okay, and so if you're able to do that, you got 62. You're good. You get an A on the. This might appear as a challenge problem on a 8th grade, 7th grade algebra word problem test that the Common Core people are very, very, very into these days. Okay, so the answer I believe was 62. Now I will show you what the kind of problem that the competition people would regard as something that is challenging. There we go, a competition of the same nature. Now, one of my students actually brought this problem to me, and I thought it was beautiful, so I decided to include it here. We're going to flare it up a little bit. Anna's mom talks to Anna, and she says, when I was your age, you were 10. And then she adds, when you will be my age, I'll be 88. What is the sum of Anna's age and her mom's age now? Now this problem, when my student, I'm just going to let you think about it. You guys can look it up. I'll give you the answer later, or I can give you the answer after, or you guys can talk to us. I'm not going to give the answer away. I will show you what you have to do. But the key observation is, again, the difference between Anna's age now and when Anna was 10. Okay, because that's what's going on here. So the language, this would be regarded as sort of a medium to hard level difficulty in an AMC 10 competition. And I bring it out here because I want to bring up some observations. This is truly hilarious. Okay, when I was sitting there with my student, I thought it was very funny, and I've gotten this has happened to me so many times that now I just laugh. And this is what's funny, I think, about it. Calculus is worthless here. Knowing calculus only makes you feel more stupid. The same is true of even more advanced math. So here's a very advanced mathematical fact that every finitely generated residually finite group is Hopfian. And this fact is absolutely even more hopelessly useless. And so if you feel like giving up, you probably actually are teachable, and this is the beginning actually of the problem-solving process. Okay, this is the beginning of the problem-solving process. So I can start you off a little bit with what it is that we actually do. So we start with the language. Anna's mom spoke to Anna and said, when I was your age, you were 10. So if we let Anna's age be n, we know that n minus 10 is the difference between their ages, okay? So we then can calculate using the same ideas, what is Anna's mom's age now? That's Anna's age plus the difference, and there's mom's age now. And then so in order to, that's mom's age now. In order to calculate what she was talking about, we've got to look at mom's age now plus the difference, because that is when Anna is her age, looking at the language, when Anna is this age. So then what will mom be? We add the difference plus n minus 10, and then mom said she'd be 88. This is mom's age when Anna is that. And you get the little equation that 3n is equal to something, 88 minus 20, which is 68, and you're done, go home. and you can then finish the problem. And I won't go into any more than that. But we start with the language, and we then go and we abstract from the concrete examples. We pretend that we knew Anna's age, and then that's what I started doing with my student. And then we saw how the numbers actually go together. We generalize, and then when we apply what we understand. And a great idea comes here. Advanced knowledge is often useless when problem solving is priceless. And so the way I was able to solve that problem with my student is by looking at it from a problem solving point of view. So let's go a little bit deeper into AMC 10 and 12. So AMC 8, that's sort of a middle of the road, middle to hard kind of problem. They appear in many different areas: geometry, algebra, pre-algebra, and so on. By the time you get to AMC 10 or 12, it's getting a bit more serious. It's 25 questions, 75 minutes. Each question is 6 points if you get the correct answer. If you leave it blank, you get 1.5 points. If you answer it wrong, you get none. They don't take away points from you, so there's no penalty. They are qualifying tests for the American Invitation Mathematics exam. If you score within the upper 5 percentile in the nation for AMC 12, you can get invited to AIME. If you score in the 2.5 percentile, you can get invited to AMC 10. And that means that for the 5 percentile, that means 95% of the people who took the test scored less than you. 2.5, that's 97.5% scored less than you. So anyone 9 to, here, Jonathan, this is answering your question.
Right.
Anyone 9 to 12 or so can take AMC 12. I think actually you might be able to take it younger than that, but certainly it actually might, unless you're really bored with AMC 8. 9 to 12 can take AMC 12, but AMC 10, they cut you off after 10th grade. Okay, right. So 9th graders and younger can take AMC 12. 10th graders can take AMC 12. 11th graders can take AMC 12. Why the American Mathematics exam, American Invitation Mathematics exam? Just qualifying for it, like I said before, it sets you apart. And students that do well on the American Invitation Mathematics exam are highly correlated with extremely strong performances in AP Statistics, AP Physics, AP Calculus, AP Chemistry, and AP Biology, and on SAT and SAT subject tests. But the converse is not true. You can do very well in AP Calculus, you can do very well in SAT Mathematics, and certainly not nearly get to the AIME. And it is a clear signal to STEM-oriented programs that you are superior in your problem-solving skills and your mathematical ability. So what do you need to know? Chime in, again, also, if you have any questions. For the AMC 10 and 12, there are 15 problems that I call the core. The Common Core, and if you can get those, you'll get 6 points for each of those problems. 3 out of the last 10, if you can just get 3 problems out of the last 10, those are the most challenging problems in AMC 10 and 12, and you can get 18 more points. And then if you're strategic and you know which answers to leave blank, and you don't try the ones that you know you can't do, you can get 7 times 1.5 more points for a total of 118. Now let's remember that number, okay? 118.5 points, okay? Let's say 118 points. If you can get that, all right, then you will get invited to this wonderful experience. Just going to it is a nice, just being able to have that certification that you were invited is a nice thing to put on your transcript. And history is on your side. Here's some recent research on this exam. If I look at the historical record for AMC 10 and AMC 12, Here is the qualifying scores for AMC 10 for the last 4 years. 103 in 2020, you can see it. 111 in 2018, 112, and so it changes from year to year depending upon the students that are taking the exam. And AMC 12 is almost always lower. I don't think I've ever seen it where it's higher. That's because AMC 12 is a more challenging test. So the average over the last 4 years was 108. Remember that number that I was telling you about, 118, that I claim is not that far out of reach. So the AMC 12 is 92, okay? And so if you can get a score, if you can get the core 15 and just 3 more of the top that I'm calling the top 10, you will go to the AIME, absolutely. Almost guaranteed. These last 4 years were pretty typical of the last 10. I just didn't feel like publishing the chart with 10 entries in it. So you might be wondering, is it easier with AMC 12? Maybe. So I'll talk a little bit about that later. Actually, I think it's next. So what we have done at BEC is researched the kinds of problems on the exam, and here's what we've discovered. And you guys can see my hand moving around here. So you can think of the AMC, both AMC 10 and 12 are structured in this way. The 5 major areas are geometry, number theory, combinatorics, that's ways of counting, interesting ways of counting, complicated counting situations, and we call algebra and functions and probability. There is a core body in each of those tests that sort of feeds the first 15 problems. And it's that body that is almost always drawn from a standard set of ideas, and it's really a syllabus. And that's what we've done, is we've organized that into some information. And that syllabus and that information can be studied and learned. The rest of the 40% of the problems, the top 10, are distributed among these 5 areas. So you have 10 problems. Never do you get all 10 problems geometry problems. So if a student was bad at geometry, they can't get any of the top 10. You usually have those 40% distributed equally. You have a couple of combinatorics, maybe 3 number theories sometimes, but almost all the time there's a good helping of these 5 areas. And most students can specialize in at least 3 of them. And you'll find your problems there, and those problems will be doable for you. Like, you might not be very good at number theory, but you're great with algebra and functions. You might not like combinatorics, but you like geometry. There might be a couple of geometry problems, a couple of algebra and functions problems. Boom, you've got it. So this is something that we've seen we can teach. We can teach that body of information, and students can study that material and master that material, and then they usually specialize in one of these, 2 or 3 of these other areas, and they're able to get those top 3. And then they are off to the AIME.
Right. Well, I think that's a big thing, because sometimes in preparation for these competitions, anyway, not everybody has access to. Some schools have some kind of coach, and sometimes it's a little bit informal. A lot of schools do not. And anyway, the fact is that you can actually study for these with knowledge of past exams and with familiarity of these tests. So they're a lot more learnable and teachable than some students feel. They just feel it's like a natural ability, which it is not.
That's right, exactly. And some people think that you have to take AMC 8. And if you don't take AMC, you can't take AMC 10.
Right, people think it's a gradual step-by-step.
Yes, exactly. Or I didn't take AMC 10, so I can't take AMC 12. No, it's not. If you are in the 11th grade, you can still take AMC 12. I had a student a couple of years ago. He had never seen competition mathematics, and he had done very well on his AP classes in the 11th grade. We started preparing after about 4 or 5 months. He did perfectly. He was invited to AIME in his senior year of high school, and he had never seen mathematics before, competition mathematics before. Just studying that core group of problems and getting good at like 2 or 3 of those other areas. If you're interested, a good study plan. You just mentioned this, Jonathan. You're reading my mind or something. you don't find this in school, okay? You don't find people coming up with these kinds of problems. The problems that are presented on these tests are all actually compliant with Common Core, but they go much deeper and they require much more comprehensive understanding of mathematics. They're made up by mathematicians themselves. You don't find math people in high schools, unfortunately, necessarily able to do these. I had a student who was studying AMC 8, and she, as part of one of the requirements for her school, and she brought it to a teacher for our competition, AJ tutoring, and the tutor was a credentialed teacher, and the teacher could not solve the problem for it. Poor H. I felt bad. It was good that that she also knew me, because her tutor was not able to get it. You don't necessarily, just because you get your credential in teaching, just because you're an AP Calculus teacher doesn't necessarily mean you're able to teach some of these problem-solving techniques if you haven't thought about these kinds of problems. What does a good program look like? So that's sort of something that I want to address in the last couple of minutes here. Well, I have to say,
Looks like
we certainly do. I would be chagrined if I were to say that we don't do this. And what I'm going to say is certainly something that that is true for us. But anyway, seriously, many great programs are out there, and I believe that BECs is one of them. And you can put together your own program. And so I want to take a look at what anything that you do should involve. First of all, you might have heard about Art of Problem Solving. I'm not sure if this website is accessible for our Chinese friends, but certainly in the United States, it's accessible. And many people think that it's a useful source of solutions, and I have read many solutions, and I am appalled at the level of gory detail, absolute missing the point. And so I don't recommend that as a way to actually learn, trying to read their solutions and see. Those solutions are often posted by students. Sometimes they say the solutions are regulated, they're monitored. I've seen lots of mistakes out there. Also, the most substantial is oftentimes they don't publish the correct problem that came in the competition. So for that reason, I recommend you first go to the Mathematical Association of America's website and check out their resources for AMC 8,
Right.
10, and 12. They have plenty of resources.
Right.
Spend the $20 to get the practice exams that they send you. They're the real thing. They come with their solutions, which involve the actual idea behind the problem solvers. And that's where you will learn the kinds of ideas that they felt should go into the solutions of the problems. AOPS stands for Art of Problem Solving. The discussion forums there are good. So I highly recommend reading the chats and the discussion forums there on some of the problems. For harder problems, when you get close to AIME or after you've been accepted and you get invited to AIME, there's a website called Math Overflow, and there's lots of very advanced problems there, but a lot of people post competition questions there. That's a very good resource.
Right.
Also, the Math Counts website, even though they're solely devoted to middle school, they have a lot of good resources for starting problems. Every good program must, so these are sort of this is a sort of minimal things that you have to have in any kind of good program. You have to address what I'm calling the big five, and that is number theory, geometry, probability, combinatorics, algebra, and functions. If you don't address one of these, you really severely curtail your ability to actually get into that range where you would be actually eligible. if you don't master all of the, or at least get exposure to, I'm not saying to master all of them, you have to understand the core, what I was calling the core areas of all of these. It's still fine to just take the AMC 10 and AMC 12. You might not necessarily make it into the AIME, but it's still fine. You'll have those scores to at least put on your college application as well. You should also focus on constructive methods for problem-solving situations, for solving the problems. The difference between constructive methods and non-constructive methods is where you come up with the answer. So when I came up with the answer with that problem, I said the answer was 62. I got the answer. I didn't pick the answer out of a section of a number of possible choices in multiple choice. Many problem-solving schools will try and show the students how to, when you see this situation, pick this answer. When you see this situation, that's not the way it works. You will run into problems very quickly. The AIME is not a multiple choice test. The AIME requires that you come up with the answer and enter an encoded version of the answer that they have a little scheme for. I won't get into that. But you actually have to come up with the answer to the problem. You can't guess it from a list.
Yeah.
So get into the habit of constructing the answer yourself, not playing off the answer choices. Also, you want to be able to use genuine problems from real tests as practice material. And that's one of the reasons why I don't recommend Art of Problem Solving for this. Oftentimes they botch the actual statements of the real problems. And then it's a long time before it's pointed out to them. And then sometimes they don't even change it after that. And of course, you could have trainers like Peter ready at hand, but anyway, I'm just sort of kidding. So those are the, at least someone like me, who perhaps if you have someone who you can talk to, either a friend or other people that take these, have taken these exams before, been through this process, that's very, very useful. Okay, so what happens if you are invited to the AIME, then what? Okay. It's not like AMC 10 or 12 where you can take it as much as it's offered twice each year. AMC 10 is offered twice, AMC 12 is offered twice, so potentially 4 times you could take those classes, those tests if you're a freshman or a sophomore. Once you're invited to the AIME, you've got to take that and you don't get another chance, so don't blow it. So make sure you are in shape, and this is why I say constructive methods. If you are used to looking for the answer among the answer choices, in 2 months you're going to have to take the AIME. It's very hard to adjust your style, so that's why it's very good to be used to finding the answer, not just guessing it or ruling out possibilities. I do recommend the Art of Problem Solving's text pre-calculus. That's a good start. Once you, even for practicing for AMC 12, there's a lot of very good information in there that comes up on AIME. Many of their drill problems are actual AIME previous test problems, and they work out the material in their book very well, as opposed to some of the stuff that's on their website. Even better is the Mathematical Olympiad series. Again, just contact us if you want more information. I'm just putting it up here for you. There are many great resources. This is much better. This is a whole series. I've got about 4 volumes in the series. I think they're adding more all the time. This is published by the East China Normal University Press and through the World Scientific publishers. And there's also a book, I just checked it out, and I think that it is available in PDF form. It's an older book. It's called Problem-Solving Through Problems by Larson. And you can also pick it up on Amazon. Used, it's pretty cheap. It's a paperback, and lots of great problems. It's a streamlined single volume version of what you would find. I said 4 there. I'm sorry, that should read 3. I think I had more examples in my original. So it's a streamlined version of this one. It's where this one goes into elaborate depth. This one gives you an overview. The only thing with this one is there aren't as many solved problems or problems with solutions. There are some solved problems, but there are many problems without solutions in this one. And so, and then the idea is you should do all of the above, and then also have a good trainer nearby. That's the best. At this point, my closing advice. So you've gotten involved, or you've gotten involved with this, and you're now studying for the AIME. I did say that we would talk a little bit about AIME, so in the last couple minutes here. So number one, this is not just for AIME, but even just entering the whole idea of competition mathematics, like Lillian. Remember Lillian in the beginning? She went from doing very, very well to all of a sudden at Stanford University math camp, she was not doing very well. And she had to revisit her problem-solving habits and her study habits with regard to these ideas. And she spent a bit of time in this region here, and you just have to accept that you're not going to be that great at this stuff for a while, and then you're going to start seeing improvement the more you do it. Once you master that core, remember that core 15, that body of that core 15, that's when you're going to start actually seeing, oh, I actually might have a chance at this, and it's going to get exciting. And the more you actually are able to get 2, 3 in that last group of 10, that's when you're going to start moving up around in this area. And it's about here that you actually get invited to the AIME. Okay, so if you can get through this curve, and I don't mean this to mean a lot of time. It can be 3 months, it can be 4 months. It depends upon how fast you want to work yourself. We have courses, we have individual tutoring, individual programs that people can coach you through. So number 2, when you get to this stage, I say when, not if, because I believe anybody who's kind of interested in this certainly can get there. So not when, not if, but when, you, I believe, will be an official mathlete. You will not be a flash in the pan proficiency person. You will be an official mathlete. You will not just be a competition mather. And so mathlete, beware, if you get this far, it gets tougher for you, okay? At this point, there isn't really anyone who can teach you the test. All right, sorry, okay. There will be people who will try to sell you on the idea that they can treat you, so be careful about people who are trying to take your money. There isn't anybody who can really show you. AIME, like I said, is not a strategies, oh, do this and pick this answer. That's not the kind of test. And as you get further along in these competitions, it starts to actually get into mathematical proof, where it's impossible to select the proof from a right answer. So anyone who tries to tell you that they can teach the test is just, they haven't thought about that. They don't really understand what these kinds of things are about. And also, mathlete, be fair. If you get to this level, so a strong and qualified trainer doesn't, they do not solve problems for you. Anyone who's a good trainer will not do that, because if you get to this point, it's kind of like you're a sprinter. Your coach can't go and sprint the race for you. They guide you through exactly the exercises you need to strengthen your problem-solving skills. They know how to do that, just like a good violinist who is a good teacher might not even be able to play as good as Jonathan, but he knows what Jonathan needs to study. Sure. He knows that Jonathan needs to know Bach's concerto in A minor, and before he can move on to X or Y, other pieces, right, and so on. They know these kinds of things, and that's what a good trainer knows. And so sometimes I've had this in the past. People have criticized me because, what, you can't get it? Well, no, I can, but if I do it and I show you how to do it, then these kinds of problems aren't like FOIL. It's not like completing the square. Once you do it, once you see it, it's gone. It's very hard to make up another of these kinds of problems that are given at this level. Yeah. So be fair and work with your trainer. And that's what I have to say. Happy problem solving. I hope you're interested in what we were talking here about. I certainly love it. I think it's one of the funnest things to teach. and everybody stay safe, and hopefully we'll be released from our homes sometime soon.
Yeah, no, thank you so much, Peter. I think we all learned a lot today about different competitions, the value of competitions, and then of course how you can train for them and excel in them. And we always say, you know, if you don't believe us, believe our clients. They're very happy. We still maintain 5 stars on Yelp, whether it's our consulting services, teaching services. And we really welcome anybody to please contact us, leave your email, and we'll contact you. I know a lot of the attendees are in a WeChat group, which we have tons of contact information as well. But if you can take it to the last slide, Peter.
This is the last slide here, I think.
One more.
There's one more. Oh, okay, sure.
Yeah. And then so that has more information where you can find our website. If you want to scan and do a consultation, of course you can. And then also you can follow us on WeChat. We have Facebook, all in there. And we just hope to be able to talk to more of you and follow up with those.
I just wanted to say, anybody, if you are participating in the seminar tonight, you're more than willing to have a free 40-minute consultation with me or with one of our collaborators who represents me, and we'll talk to you about competition mathematics. We can give you some advice on directions you might want to go, make some recommendations for either our courses or what you might be interested in putting together for yourself. And we can tell you a little bit more about what's out there and what's available. And so feel free to give us a call or shoot us an email or WeChat.
And Peter,